So this question is sort of an advanced Fibonacci question. Before we do the advanced Fibonacci question, let's go and just talk about the regular Fibonacci question. This is rabbits. So the rabbits, we're going to start off with rabbits. And the first rule about these math Fibonacci rabbits is you measure them in pairs. You don't count the actual rabbits. So if there's a pair of rabbits, you write it down as one. Right? And I'm going to build this up and then simplify it to the Fibonacci format, so you can see how the whole thing works together. Okay, first of all, we're going to start with youth initially. Youth rabbits in month 0, 1 pair. And adult rabbits in month 0, 0 pair. And that means total. So those are our starting conditions. 1 pair of youth rabbits, then no pair of adult rabbits. And we have this rule, the total number of rabbits is equal to the adults plus the youth. In this case, that's 1, so 1 pair total. And we have some other relationships. We know that in any month, the total number of rabbits is the adults plus the youth. Okay? What else do we know? We know a special thing. We know that in any given month, the number of youth rabbits is equal to the number of adults the previous month. And again, this is pairs, all in pairs. So whatever rabbits were adults, last month they got pregnant, and this month they're going to have babies. Okay, they're math rabbits. I don't know what the real gestation is for rabbits. All right, we know something else about the adult rabbits. You have to take all the adults you had last month. None of the rabbits ever die. Okay, and then you add that to the youth that you had last month. Okay, so last month adults got pregnant, and then they're having the youth this month. And so these are the adults who got pregnant last month, and these are the new incoming adults who have now spent their 1 month growing up. Okay? So this is a very simplified model. The babies are born after 1 month of gestation, and once they're born, they only take 1 month to start reproducing. So the way we'll write this table out, and you may think, why don't I just say this? Okay? We start off with F0 is 1, F1 is 1, and then we always have Fn plus 1 is Fn plus Fn minus 1. And that's what we're going to end up saying. Okay, so this is eventually where we're going with this. But we're building it up, and not all of our scenarios are as easy to view or as easy to visualize. So we're going to just build this up very slowly. Okay, we're going to start off with month number, and then we're going to have number of youth pairs, number of adult pairs, and the total pairs. Okay, and then we'll make ourselves a grid, however many the instructions say we should do. This is a pretty easy scenario, so we can get the gist of what's going on pretty quickly here. All right, so we're going to just figure this out. All right, month 0, 1, 2, 3, 4, 5. Youth pairs, we start off with 1, and adult 0, and total is 1. So everything in blue is what we started with, and now let's figure out from all these rules what's going on. Okay, I'm going to put some arrows here. This rule says the youth of today is the same number as adults from last month. So however many adults we had last month, we're always going to copy that number down into the next youth box. And then the next rule says the number of adults today, okay, is the number of adults yesterday plus the number of youth yesterday. So you have to add these two together. So these guys come over and join. So these green arrows are just either people living, rather rabbits living, or rabbits growing up, whereas the red arrows are new rabbits being born. And then the total here, you simply add up the number of rabbits you have. Okay, so let's just go ahead and figure out what all those values are. Okay, let's follow the first red arrow. Okay, 0. Now let's follow the green arrows, 1, and then add 0 plus 1 is 1. Okay, follow the red arrow, month 2. Follow the green arrows, month 2, add them up, you get 2. Red arrow, month 3. Green arrows, month 3. We have to add the youth and the adults from the previous level, so we're getting more rabbits now. Okay, red arrow for month 4, green arrows, total pair. Okay, red arrow, green arrow, total pairs. And we're actually seeing that we get the Fibonacci sequence here, and we could simplify the Fibonacci sequence by saying F0 is 1, F1 is 1, and Fn plus 1 is Fn plus Fn minus 1. And so that's telling us the total number of rabbits. Okay? Alright, so this is the stopping point for the Fibonacci rabbits, and now we're going to go up to the difficult problem. Now, it's not that difficult because I've given you these special tools to analyze it very carefully so that you can keep track of all your record keeping nicely, and it's not that difficult. Alright, so we have to figure out what all our rules are and then just work this out. In this case, it's going to take 2 months before they can reproduce. It's still going to only take 1 month for the gestation. Okay, but this, if there's any confusion, this is clear because I get the process started for you. What we need, since they have to wait 2 months before they can reproduce, they're actually going to be a baby category, and then a youth category, and then an adult category. It doesn't matter what you call them, but they have to have 2 junior categories because they're actually different whether they're the first class or the second class. Once they become adults, then they just stay there forever. But we're starting out. It says we start with infant rabbits, or let's say B for babies, youth, adults, total equals however many. We start with a pair of rabbits. It doesn't say whether they're babies or youth yet. It says for months 1 and 2 we still have 1 pair of rabbits, and month 3 we get 2 pair of rabbits, the elder pair and the younger pair. Alright, so let's think about this. Okay, so the important thing here is to just be very careful. We start with month 0, month 1, and month 2. So there's actually 3 months in which we have 1 pair of rabbits. So this is telling us that the babies must be 1 pair, the youth is 0, the adults are 0, and the total is 1. So that's how we're starting off in our categories. Now we have to figure out what our recursion relation looks like. Obviously the total in any month is the babies plus the youth plus the adults. But how do we transition? Okay, so how we transition is the babies in any given month is, the babies in any given month is the adults of the previous month. The youth of any given month is the babies of the previous month, and the adults of any given month are the youth of the previous month plus also the adults of the previous month. Okay, maybe you didn't get that all right away, but if you write the grid and fill in the information I've given you, then it should be fine. So let's go ahead and make this grid. Okay, so you have month, babies, youth, adult, total. And remember, this is in pairs. Trying to draw this as a double bar. There we go. So this is pairs. all of these are in pairs. There we go. So month 0, a pair of babies. In month 1, a pair of youth. In month 2, a pair of adults. Now it says in month 3, we get 2 pair of rabbits. Because it says the elder pair is still reproducing, but the younger pair has not matured yet. Right? So this is our 2 pair of rabbits. Now what's happened is, let's draw the arrows. So these arrows people get. I find that people don't have any trouble with these maturity arrows. And nobody has trouble with these arrows. But the interesting ones are when you say, aha, well, the number of adults before tells you the number of babies now. So you have to keep track of all those different arrows. Okay, we're going to continue this logic. And I'm going to set up the next grid. So, okay, I just copied this grid over, and we're going to start filling it in. So we're going to follow the light blue arrows first, between month 3, which is here, and down to here, which is month 4. Okay, and I don't want to really erase the problem, so that's why everything's getting squeezed in here. Okay, so I want to follow the little blue arrows, the maturity arrows. So we have one group of babies in month 3 that become one group of youth in month 4. There are no youth in month 3 rather. So we have nobody to bring over to the adults, but we get to keep the existing adults. Now, the existing adults are reproducing, so we do have this green arrow that goes from here down, that particular arrow. Don't forget that we have new babies being formed, and so we have a new set of rabbits. Now we have a total of 3. Okay, so again, let's not forget the reproduction arrows, then let's not forget the maturity arrows, and let's go ahead and fill everything in. Right, let's do the maturing first. We have babies turn into the youth turn into the adults, but the old adults get to join them. So we now have 2 sets of adults. But in month 4, we only had 1 set of adults, and so we only get 1 new set of babies. So that's 4. It doesn't look like we're getting rabbits very quickly, but don't worry, it will just take off very rapidly. That's part of the reason I wanted, 15 months worth of rabbits. Okay, it says for the next 15 months, but how many months of information did I supply in the problem? In the problem, I went up to month 4. Okay, so what is 15 plus 4? So that means I want you to go up to 19 months of data. Okay, so let's do a couple of these, and then we'll open up a new screen and do it faster. But let's still do it slowly for now. Okay, let's do the little light blue arrows. These are the maturity arrows. Babies turning into youth, there's a 1. Youth turning into adults is 1, plus adults staying adults, so you get 3. And then the reproduction arrow, so 2. So that's a total of 6. Something doesn't seem right. I'm just going to double check my work here. Okay, that's fine. It is right. All right, so then we go, try it again, month 7. Babies turning into youth. That one you never have to do any addition. Babies just turn into youth. They just slide over. Youth turn into adults, but there's already adults. And then adults reproduce. Okay. So we have 9. Right, I'm going to set up the grid again, and I'll be right back. Okay. At some point, you may start to notice that there's a Fibonacci thing going on. Hopefully you will. But let's do a few more of these, and we'll slowly speed up the process. Okay, babies you can always move over. Youth plus adults, and you get the new babies. And you can add these up later, or you can add them up now. You should notice that you can keep the babies, youth, and adult tally separate from the total, and you can go through and get the total later. It doesn't really matter which way you do it. Okay, so we've got the adults reproducing. There we go. Okay, move over the babies, add up the adults, new babies, move over the babies, add up the adults, new babies, move over the babies, add up the adults, new babies, move over the babies, add up the adults, new babies, move over the babies, add up the adults, new babies, move over the babies, add up the adults, new babies, move over the babies, add up the adults, new babies, move over the babies, add up the adults, new babies, move over the babies. Let's start to add. I'm finally needing a calculator. Let's see, 189. I probably already made a mistake. 277, new babies, move over the babies, add up the adults, and new babies. Okay, now we can start adding, but guess what? You should notice that we created this interesting sequence. Okay, so the important thing to notice is that we're getting this same sequence in every single column. So that's the cool part. So you see 3, 4, 6, 9, 13, 3, 4, 6, 9, 13. It has to be, right? The number of babies has to equal the previous number of adults, but the weird thing is that they all kind of add up the same way. So for example, that's 19, and we see 28. And what happens after 28? 41. Double check that I'm not lying to you, because you shouldn't just take my word for it. You should think about whether it makes sense. And so then you get 60. Is the next one going to be 88? Double check. Should be 129. Double check. 189. 277. 406. And the last couple you're going to have to kind of add up by hand, which is 189 plus 129. 189. Yeah, right. 189 plus 129 plus 277, 595, and let's see, 277 plus 189 plus 406, 872. You should convince yourself this makes sense and that the total does have to equal all these parts, and that it makes sense why the baby sequence and the youth sequence and the adult sequence have to be the same, right? Because the adults give rise to the babies, which give rise to the youth. So those have to be just delays of each other, right? But why is it that the total has to also be the same sequence? I'm going to leave you with that to ponder why this makes sense. Okay, because if you think about it, it will make sense. All right, talk to you later.